So, are you able to see the screen now? I have shared the screen.
Yes.
Okay. So, today we are just going to do some algorithms. Okay, that's all. All right. So this is one graph. These are not the weights. These are the names of the vertices. Okay. The numbers you see here, these are not weights or edges or weights or vertices. These are just the names. Just like we give A, B, C, D, E. Here they have even names 1, 2, 3, 4. That's all. Right. So question. Do DFS. Question 2. Do DFS. Is that okay? And question 3. Find shortest path between any two pairs of vertices. So let's say 1 and 5, 8 and 11, 7 and 9. Okay, 1, 5, 8, 11, 7, 9. Is that okay? So you want to try? We have done this, so try this quickly. So if you want, let me mention, you can start DFS with vertex 6. You can start DFS with vertex 8. Okay. So let's do BFS, starting with vertex 6, right? So I'll just color the edges here so that you can draw it easily. So starting with vertex 6, what do? We basically take all neighbors without forming cycles, right? So from 6 you have this edge, and this edge, and you have this edge. Okay. Alright. Now we have 4, 5 and 10. So again we are doing BFS. So let's start with 4. Okay. So since these are numbers, we have to start in some order. Let's start and do it in ascending order. Okay. So 4, from 4, what all edges can you draw without forming a cycle? You can draw this one.
So
Yeah.
सर आपकी वॉइस क्लियर नहीं आ रही है, समझ में नहीं आ रहा आप क्या बोल रहे हो।
हाँ लेकिन मैं BFS ही कर रहा हूँ ना।
हाँ बट मतलब वॉइस क्लियर नहीं आ रही है ये
हाँ
बोल
तो
रहे।
ठीक है, वॉइस अगर ठीक नहीं आ रहा है तो ध्यान मत दो वॉइस पे, BFS करते जाओ, मैं वैसे भी आरो बना रहा हूँ यहाँ पे, ठीक है। So we start with vertex 6 and then we have its neighbors 4, 5 and 10. From 4 we are again doing BFS. So we go to 7 and 3 and no more because the only other neighbor is 6. So we cannot do anything more. Starting with now 5, we can go to 3 but 3 will form a cycle, right? The other 3 edges are here. So we cannot join 5 and 3. So we can only join 5 and 9. Nothing else. So these 3 are already there. Once that is done, from 10 there is only one choice now, 10 to 11. Okay, that completes the second stage. And now the neighboring vertices are 7, 3, 9 and 11. So now let's again go in the order. Let's go in the order numerically. So numerically ascending order. So let's start with 3. 3 and 5 will form a cycle, so we cannot join that. 3 to 2 we can, and that's the only thing that we can choose. Next is 7. From 7 there is only one choice, so that is 8. Right. Next is 9. From 9 there is nothing going outwards, so no choice. Then we have 11. From 11, all its neighbors without forming cycle is basically 11, 12, 11, 13, these two edges. And now if you see, are we done? Not really. Last vertex 2 is remaining, so 2 and its neighbor 1. That's it. Okay, so this is a spanning tree which we obtain by doing BFS. Is that okay? Alright. Similarly, let's do DFS. So we are doing DFS now. And remember, whenever we have DFS, we will always have backtracking. Okay. Now we are not going to mention it again and again, but we will have backtracking. Okay. So DFS from 8, if you start, then there is only one choice, 7. From 7, we go further ahead, we go to 4. From 4, we have to choose a path. So here, just for a choice, I will choose smallest possible label of the vertex possible. Okay, you can choose any other vertex also, as we have already seen. Arbitrary choice. So 4 options are 3 and 6, right? 4, 3 and 4, 6. So let me just pick 4, 3. Okay. Now from 3, I can go to 3, 2 or 3, 5. Let me choose 3, 2. From 2, then I only have one choice. I can go up to 1. From 1, I cannot go anywhere. From 1, I cannot go anywhere. So now I have to backtrack. I go back to 2 because that's where I came from. From 2 also I cannot go anywhere. So again I backtrack. I come to 3. From 3, there is a new direction possible. From 3, I can go to 5. Right? So I go to 5. From 5, again I have choices. Right? So I can go to, let's say, 9. Okay. Now from 9, I cannot go anywhere. So I again backtrack. I come back to 5. From 5, is there a new direction possible? Yes, there is. 5 to 6. From 6, can I go anywhere? I can go to 4 or 10. If I go to 4, it will form a cycle because it will form this square. So I cannot go to 4. I can only go to 10. From 10, I can only go to 11. From 11, now I have choices, right? So let me go to 12. Arbitrary choice. From 12, I can only go to 13. And now I have seen this completely covers every vertex, right? Every edge covers every vertex is covered at least once. So this completes DFS because all vertices have been covered. Okay. All right. So now the third question is about shortest path between vertices, and we have already seen in theory in our lecture that shortest path can be obtained by looking at the BFS tree, breadth first search tree, by looking at the BFS tree. right? So, but we have a BFS tree here. So what do we get? So shortest paths from the BFS tree for the vertex 1 to 5. What is the path that you have? So you are supposed to look at the top one, the BFS tree. Okay. So 1 to 5, what is a unique path? You have 1 to 2 to 3 to 4 to 6 to 5, and that is the shortest path. Okay. 8 to 11, what do you have? Let's check. We have 8 to 7 to 4 to 6 to 10 to 11. Okay. 7 to 9, what do we have? From 7 to 9, again we have something similar. We have 7 to 4 to 6 to 5 to 9. Okay. So these are our shortest paths obtained from the DFS tree. Okay. Is that correct? Oh no, sorry. Sorry. Mistake. Shortest path you can only measure using DFS from the vertex that you start out with. So let's give choices from 6 to 6 to 13 and 6 to 8. You understand the difference? So this is a mistake which even I have been making. So listen very carefully. Whenever you want to find shortest path between any two vertices, you should start BFS from one of those two vertices. You cannot start BFS from somewhere else. You have to start BFS from those two vertices. So we started BFS from vertex 6. Therefore, now we can measure shortest path from 6 to any other vertex, not any two vertices. Okay. So that is the only important point here. So now the shortest paths. For 6 to 2, shortest path is now 6, 4, 3, 2. That's it. 6, 4, 3, 2. From 6 to 13, just go on tracing this. 6, 10, 11, 13. 6, 10, 11, 13. From 6 to 8, 6, 4, 7, 8. 6, 4, 7, 8. So these are the shortest paths. Okay, very important. Otherwise, you'll make mistakes. Very important. Whenever you want to find the shortest path between two vertices, your DFS should start from one of those two vertices. Okay, not arbitrary. Okay, so that is something that we have. All right. So let's take another example. Okay, this is one example. The question is perform Kruskal's algorithm. Okay, and you can start from some vertex. So start from, well, you don't have to start from a vertex here since it's Kruskal. So it's okay. Yeah. So perform Kruskal's algorithm. So think about it. Take 2 minutes, and then I'll start writing. Okay, so Kruskal's algorithm, okay, for finding minimum weight spanning tree, right? And here there is no condition that the edges that you choose should be joined to each other. You just go on greedily picking minimum weight edges, right? So what's the first edge you will pick? If you look at all these edge weights, okay, these are the weights on these edges. The alphabets A, B, C, D, E, F, G, these are all the names of the vertices. If you look at the edge weights, the minimum edge weight is 1 here, the edge HI. Okay, so you have to pick this edge. So you have to pick this edge. Okay, once you do that, what's the next minimum edge weight? Is there 2? There is 2. There are 2 edges with edge weight 2. You can pick any one. Let's pick this one. Okay, you see. Okay. After this, what's the minimum edge weight among remaining edges? Again, 2 is possible, so you can pick this edge. After this, what's the minimum edge weight? It's 3, so you can pick this one. Again, minimum edge weight remaining edges is again 3, so you can also pick this one. What is the minimum edge weight now among the remaining edges? 4, but you can choose only those edges which do not form a cycle. If you pick BD, it will form a 3 cycle. If you pick HJ, it will form a 3 cycle, so you cannot do that, right? So you can only pick GH now, but that's all right. Now among the remaining edges, what is the minimum edge weight? You have 5, but if you take 5, then GI will form a 3 cycle. You cannot do that. If you put that away from the further remaining edges, what is the minimum edge weight? There are edge weights 9, 10, 7, 8, 6. Okay, so 6 is possible, but again, if you take edge AD with edge weight 6, it will form a 4 cycle A, D, C, B, A. So you cannot pick that. So among the remaining edges now, the minimum edge weight is just 7. Okay, there is no other edge with weight 5 or 6 that you can choose. So now it is just 7. Alright. Once you pick this, among the remaining edges now, what's the minimum edge weight? 8. Okay, so there are 2 possibilities. So let's pick any one. Let's pick this one. After this, once again, if you look at it, again you can choose an edge of weight 8. You can choose this one. Right. Now among the remaining edges, do you need to pick anything? So every time when you go to pick the next new edge, you have to first see whether all the vertices have been covered or not. The moment all vertices have been covered, you don't have to do anything more, right? So if you see now, all the vertices are incident on at least one of the pink edges at this stage. Okay, no vertex is remaining. So this is the spanning tree, the minimum weight spanning tree. Okay, so this is the minimum weight spanning tree. So, and what is the minimum weight now? So minimum weight is, now you can just sum these weights up. Okay, so the weights are, let's say I'm counting from the left hand side, 3 plus 2 plus 2 plus 8 plus 8 plus 7 plus 4 plus 1 plus 3. That's all. Right. So 2 plus 2, 8 plus 8, 20 already. 3 plus 7, 30. Okay. So that is 38. Minimum weight is equal to 30. Is that okay? And this is a minimum weight spanning tree. All right. Let's do Kruskal. Sorry, we have done Kruskal's algorithm. Let's do Prim's algorithm. Let's do it on the same graph. So Okay, from Prim's algorithm. So once again, the first edge you have to pick the minimum weight. There is no change there. So again, edge weight 1. Now things change in the sense that now you have to pick minimum weight edge without forming cycles, but at the same time connected to one of the existing edges, not far away. Okay, connected to one of the existing edges. So you are supposed to look here itself. So edge is, this edge is 1, weight 1. Among the edges connected to this, which one will you pick minimum weight without forming cycle? You can only pick this one. Now among the edges connected to these, now you cannot pick Hj which will form a cycle. Now you have Gh of weight 4, Gi weight 5, then If, Jf, Je. That's all. So the minimum weight now is Gi with weight 5. Okay. Now from here, if you look at it, the edges that are incident on these are now either Dg, Cg, Fg, Fi, Fj, Ej. These are the only ones. So weights are 9, 9, 7, 9, 10, 18. These are the only possible ones. So the minimum weight among these is 7. Okay. Now among these, without forming cycle, you have these choices Bg, Cg, obviously. You don't have Fig, Fj. Those are gone. You have Ej. And you have Bf and Ef. These are the new ones. So 9, 9, 18, 10, 9, 8. Okay, so 8 is the minimum choice that you have. There are two choices. You can either pick CF or you can pick EF. Let's pick one of them. Let's pick CF. Now if you look at the remaining ones, a minimum choice that you can pick is BC with weight 2. It's as small as possible. Okay, let's do that. From the remaining ones now, the minimum weight, again you can pick DC with weight 2. So let's do that also. Okay. Now, from the remaining, now how many vertices are remaining? Only A and E are remaining to be covered. All other vertices have been chosen. Okay. So from the remaining now, you need to look at edges DA, BA, BE, FE, and that's it. Nothing more, right? So what are the edge weights? 6, 3, 9, 8. So the minimum edge weight is 3. You pick this. Right? Now among the remaining ones, last choice, you only have to connect E, so there isn't much of what you can do. You can either pick AE, you can pick BE, you can pick FE. Right? So FE has minimum weight 8, so you choose this one. Is that okay? So this is the minimum weight spine weight. And now what is the minimum weight when you do it this way? So again counting from left, it's 3 plus 2 plus 2 plus 8 plus 8 plus 7 plus 5 plus 1 plus 3. And that is equal to, so again 20, 30, 39. So did you make a mistake somewhere? It should become 38. Yes, maybe I did a mistake there. Okay. So just check. Okay. So either both should be 38 or both should be 39. So I might have made a mistake in summing this up. So anyways, just check that. But this is how you will work through Prim's algorithm. Okay. So that's another example. Let's take a directed graph. Let's take this one. So this is a directed graph. Don't bother about what the vertices look like. We are more concerned about directions. Right? So now question is, find a topological sorting. Okay, find a topological sorting. So how will you do topological sorting? Just find a DFS, depth first search. Just find a DFS. Okay, that's what you have to do, right? So this is an acyclic directed graph, so you don't have to worry about acyclicness. It's already given to you. Okay. So let's do depth first search starting from. So let's do DFS from top vertex, from this vertex. Okay. So from here, if I do DFS, I can choose this path and put in directed paths. Okay, directed DFS. Then I go this one. Then I go this one. Now I cannot go anywhere else. I backtrack. I can go here. Then I cannot do anything further. I backtrack. Then I can pick this one. Then I go back. I have to backtrack again. Then I again backtrack and go to the top, right? Then I can pick this edge. And from here, I can either go here or here. But if I go here, I'm going back to something I've already chosen. I don't want to do that. I go to a vertex I've already chosen. That's not what I want. So I'll choose this one. Okay. So this is a DFS. Okay, this is a DFS. And now what is it? Now just write down these paths that you have. Okay, so you have first path is this thing. So let's take it. This is first path. Okay, then you take the second path and the third path and then the fourth path. That's all. Okay, so let's write it down in that order. So we have this vertex followed by this vertex followed by this vertex followed by 8, right? Then we have the other path, which is this vertex followed by again a plus vertex followed by E, right? The second green path. The third green path is what you see on top, star to C. The fourth path is plus to B, plus to B, right? And now between these, what will you do? Between these, you don't do anything. You just connect them and that's enough. Okay, so just connect them. You see, you identify the paths in the DFS that you have, write them down in a row, and then end of one, you connect it at the beginning of the other. That will be your topological sort. This whole thing wrapped around is your topological sort. Okay, so the final topological sort will look like this. So you have plus, the same thing I'm writing now in the proper order. You have the star, then you have a plus, then you have A, right? Then you go around, you again get a plus, another plus, and then you get E. Then you go around and you get a star, and then you get C. Then you go around, you get a plus, and then you get B. You understand? So that is what I meant by wrapping around. Okay. So this is a topological sorting. Is that fine? So this is how you get a topological sorting from a DFS. So yeah, so I think it is time up now. I think probably only have a few minutes for the next lecture. So I'll stop here now. Okay, and next lecture again tomorrow we'll continue with problems only related to graph algorithms. We'll just get more and more practice with this thing. All right. So that's it for today. Announcement is tomorrow 8 o'clock we have the long quiz. Remember, tomorrow is Thursday. Okay. So tomorrow 8 o'clock, 8 to 9 o'clock. we will have the long quiz. Okay, so yeah, good luck. I'll put up the instructions and group division, everything as usual tomorrow morning. Okay, so the quiz will have 40 questions. As I told before, 40 questions, 40 marks, 1 hour. Now we have 5 units, right, in our syllabus. So it's 40 questions, so 8 questions per unit. Okay, and your whole quiz is divided into 5 parts. So for each group, I will give you 5 links. Okay, part 1, part 2, part 3, part 4, part 5. Each part will be one particular unit and it will have 8 questions. So you have to complete all 5 parts, which is total 40 questions within that 1 hour. Is that okay? So yeah, that will be the quiz 8 to 9. And from 9:15 or something like that, we will continue with some more problems. Is that okay? So we will stop here now. Okay, thank you.